All right, guys, moving on to slide 3, we're going to start talking about some monosaccharides. These are simple sugars. They're the simplest carbohydrates, so there's not a whole lot going on. And they cannot be converted to simpler compounds. These are going to be your basic. This is your bread and butter of saccharides, and we're going to use these to kind of build other molecules. All right, here's a couple. We have glucose here. It's a six-membered carbon chain. If you blow up the slides, you'll see that there's 1, 2, 3, 4, 5, 6. This is what it looks like when it's in a ring structure, and that's what we're going to be talking about soon, and I'm going to go through it real slowly, but it can be a little bit confusing. Fructose, there's still 6 carbons here. However, it's a 5-membered ring instead of a 6-membered ring. And the big reason for that is you can see glucose is an aldehyde, whereas fructose is a ketone. And if we look over here at our notes, you could see that monosaccharides are 3 to 6 carbon chains. So we're going to have something that's pretty short. Every carbon has an OH group, right? So just know that every single carbon is going to have an OH group with the exception of one. And if we look back over here on glucose, you can see carbon number 1, the aldehyde carbon. This is the carbonyl carbon. That means it's got a carbon-oxygen double bond. This does not have an OH. Moving over here to fructose, you can see our ketone. That does not have an OH either, but you can see that the rest of them all have OH groups on it. The carbonyl group is on carbon number 1 or carbon number 2. We always stack these. This hopefully looks familiar, like Fisher projections. We always stack it so that the carbonyl group is closest to the top. And you can see we've done that with the aldehyde as well as the ketone. And we start counting carbons from the top. So here in an aldose, or you'll find out what an aldose is later, that's carbon number 1. Here with a ketose, carbon number 1 is this one here, and then carbon number 2 is this one with a carbon-oxygen double bond. So you can see we have our glucose and fructose here. All of our sugar, all of our monosaccharides end in ose. You might hear me say, when we talk about saccharides, I might call them sugars as opposed to saccharides, but it's the same thing. They all end in ose. We have trioses, tetroses, pentoses, and hexoses. And all that does is tell us how many carbons are attached to it. So you can have 3, 4, or 5, 3, 4, 5, or 6 carbons in the chain. And if we move on down here to slide 4, disaccharides, this is, it's just 2 saccharides connected, all right? So if we look at this for a minute, this is, if we look at this information here, 2 monosaccharides join, contain at least 1 acetyl carbon. And if you remember what an acetyl carbon is, it's right there, right where my mouse is pointing. That is your acetyl carbon, because you have a single bond to an oxygen and another single bond to an oxygen. Okay, so that's what we have going on here. And these are 2 disaccharides, lactose. I'm sure you've heard of it. Lactose is glucose and galactose. All right, that's what it is. Glucose and galactose bonded together. Those are our 2 monosaccharides. And those that are lactose intolerant do not produce the enzyme that can cleave these monosaccharides. That's why it causes some digestive issues. Sucrose is glucose here and then fructose here. So we have another acetyl carbon right there. You can see it's bonded to an O and bonded to this O. Because of that, we have acetyl carbon right there. That's how we bind 2 monosaccharides together in order to get a disaccharide. And then if we move on down, here you can see just a little acetyl drawing just to make sure we remember what those are. If we move on down to number 4, these are polysaccharides. We're not going to draw these. I'm not going to get too into this, but these are 3 or more monosaccharides joined. These are like starches. There's no carbonyl groups. What you can do with these is hydrolyze them, adding water, in order to make simple monosaccharides. And so when you start talking about starches and foods like pasta, bread, rice, and potatoes that are very starchy, when you eat those, that starch that you eat will get hydrolyzed into monosaccharides, and that's what your body uses.